Learn VR MR. Come to the Spatial XR community.
Earlier, we introduced the first method of handling spatial input using the XR Touch Space Interactor. Now, I will introduce the second method of handling spatial input. First, let's duplicate the current scene and rename it. Okay, now we are in the duplicated scene. For the second method of handling spatial input, we only need to change the interactor-related scripts, while the interactable components on the objects remain unchanged. Now, I can delete these two interactors and also delete the main camera. Okay, the other objects are retained. Then, in the hierarchy panel, right-click, select XR, and click on XR Origin VR. This is equivalent to a player object structure. Let's look at the main camera child object under the XR origin. This main camera object now has a new component called Tracked Pose Driver. When an object has this component, it can be tracked by the headset. Since this component is added to the camera object, our camera object, which represents the headset itself, can be tracked. Of course, in a shared space, since head data cannot be obtained, this component is not very useful. However, in an exclusive space, because we can obtain head data, and the headset can be tracked, we can retrieve the head's position and rotation data. In an exclusive space, this feature can be used to develop unique functionalities, such as making a U-I follow the rotation and movement of our head. This requires the Tracked Pose Driver component to give the headset or the head camera the ability to be tracked, allowing us to use the tracking data for other operations. Okay, next, we will create several child objects under the camera offset object to manage the related interactors. First, create an empty child object and name it Primary Interactor. Then, click on this object, select XR, and click on Near-Far Interactor. Okay, now a child object has been created under the Primary Interactor object, and this child object has the Near-Far Interactor component. As the name suggests, it is also an interactor needed for interaction. This interactor comes from XRI and is mainly used to handle both far and near interactions. Far and near interactions correspond to indirect pinch, eye-hand interaction, and direct pinch, close-range finger pinch interaction in spatial input. Now, expand the Near-Far Interactor object. Its child object has an exclamation mark error. we can see that this object has a line renderer component, and the exclamation mark error indicates that the line renderer component is not supported by Apple's Reality Kit. Therefore, when developing applications based on Reality Kit rendering, a common issue is that some Unity components are not compatible with Reality Kit, and we cannot use the built-in line renderer. The line renderer is mainly used to render rays, but we don't need this component here, so we can delete this object. Now, go back to the near-far interactor. It also has many scripts. Originally, the near-far interactor was not compatible with Vision OS, but XRI has introduced some new scripts to make it compatible. Here, we will keep the near-far interactor and the interaction attached controller scripts, and delete the other scripts below, as they are not needed. Next, add a script called Spatial Touch Input Reader. In the third parameter, you can see two parameters, and there's also a touch parameter. By looking at their names, you can infer that this script is used to handle spatial input, as these three types correspond to the spatial input types in Vision OS. Then, we need to associate the Spatial Touch Input Reader with our near-far interactor. Since the near-far interactor itself handles both near and far interaction types. And the Spatial Touch Input Reader has selected Indirect Pinch and Direct Pinch. Under the supported pointer kind parameter, which correspond to far eye-hand interaction and close-range finger pinch interaction, respectively, the spatial input types defined by this script align with the purpose of the near-far interactor. By associating it with the Spatial Touch Input Reader, our near-far interactor can now handle spatial input in Vision OS, effectively making it compatible with Vision OS. Now, find the Input Configuration section. Under Select Input, click here and change it to Object Reference. Then, drag the Spatial Touch Input Reader script from this object to the Select Input field to complete the assignment. Now, the near-far interactor and the Spatial Touch Input Reader script are successfully linked. Next, we need to add two more scripts. Search for a script called PointNearCaster and add it to this object. Then add another script called Vision OSFarCaster. Okay, now find the parameter in the Vision OSFarCaster script. Drag the Spatial Touch Input Reader script from this object to this field to complete the assignment. Alternatively, you can directly drag the object here, and it will automatically reference the Spatial Touch Input Reader script attached to the object. Now, the near-far interactor script is fully configured. Our Spatial Touch Input Reader script only defines two types of spatial input. There's another type called touch, which corresponds to finger poke interaction. The core idea of this second method of handling spatial input is to first add an original interactor from XRI, and then add some additional scripts to make the original XRI interactor compatible with Vision OS. This is different from the first method we introduced earlier, which involved adapting a script from polyspatial to XRI. However, the final results achieved are the same. Now we have added near and far interaction functionalities, but we are still missing the poke interaction functionality. We will follow the same approach. In XRI, there is already a poke-related interactor. Our goal now is to make this poke-related interactor capable of handling spatial input in Vision OS. Adapting the original poke interactor to Vision OS interactions. Now we can create a new object because the poke-related interactor is currently not available in the XR options. So we need to configure it from scratch. Create an empty object and name it poke interactor. Then add a script called XR poke interactor and a spatial touch input reader script, and change the third parameter to touch. Next, we need to associate the spatial touch input reader script with the XR poke interactor script. Now add a new script called poke interactor toggler. And drag the poke interactor object to this field to complete the assignment. Then, drag the spatial touch input reader to this field to complete the assignment. The poke interactor toggler connects the XR poke interactor and the spatial touch input reader. This poke interactor toggler script can hide the XR poke interactor when the program starts running. When a finger touches an object, it detects the touch input and reactivates the XR poke interactor. At this point, the XR poke interactor will handle poke-related interactions, such as pushing a virtual button. Originally, the pushing process was handled by the XR poke interactor. However, in Vision OS, we can only detect spatial input, which is of the touch type. This input is considered a touch action and cannot fully simulate pushing a button. In this case, we need to detect the touch type in spatial input while also utilizing the original XR poke interactor from XRI to achieve the button pushing effect. Therefore, the poke interactor toggler script bridges the touch input in Vision OS with the XR poke interactor in XRI. Okay, now we have configured an interactor to detect the first spatial input. Since spatial input can have up to 2 inputs, we can add another identical interactor by duplicating it and renaming it. This interactor will handle the second spatial input, so I'll name it secondary interactor. Now, find the near-far interactor object for the second spatial input and locate the spatial touch input reader script on it. There's a parameter called isPrimaryTouch. If it is the first spatial input, you need to check this option. If it is the second spatial input, you need to uncheck it. Therefore, we can determine whether the interactor handles the first or second spatial input based on the isPrimaryTouch parameter in the spatial touch input reader script. The same applies to the spatial touch input reader script on the poke interactor. Since it handles the second spatial input, we uncheck this parameter. Okay, now we can try running the program to see the actual effect. Okay, I've entered the scene, and the far and near interaction effects are working normally. Now, let's try using the index finger for poke interaction. However, you'll notice that my finger cannot push the button. But if you observe carefully, you'll see that when my index finger touches the surface of the cube, a light spot appears at the point of contact. This indicates that the touch input has been detected by the cube. However, we cannot push the cube. Earlier, when we introduced the first method of handling spatial input, we were able to push these cubes. But now, after using the XR poke interactor, we can no longer push them. Why is this? In the previous demonstration, when my finger touched the cube, a light spot appeared at the collision point. Indicating that the touch spatial input was detected. However, we couldn't push the cube. In the first method of handling spatial input, we were able to push these cubes. Additionally, we added interaction events to the cube objects. So when a cube was selected and entered the select state, its color would turn green. But just now, when we touched these cubes, they did not turn green. This means the select interaction event did not occur. The select interaction event is part of the XR grab interactable script on the object. Now, let's look at the near-far interactor. This near-far interactor can handle both near and far interactions. The interaction process of using the index finger to touch and push an object is also considered a near interaction by the near-far interactor. Therefore, the direct pinch in spatial input, which involves pinching with fingers to grab an object at close range, and the touch interaction type, which involves using the index finger to tap and push an object, are both considered near interactions. However, the XR poke interactor has stricter requirements for what constitutes a poke interaction. For example, when we use the index finger to push a virtual button, we can push the button in one direction until it reaches its limit and cannot be pushed further. This complete interaction process, where an object can be pushed in a specific direction with a limited range, is what the XR poke interactor considers a poke interaction. Thus, the XR poke interactor has certain restrictions on what qualifies as a poke action. Simply touching an object and applying a force to it is considered a near interaction. Currently, we are using the near-far interactor to handle near interactions. However, the spatial touch input reader bound to it does not accept the touch type of interaction. Therefore, when we touch the cube with our finger, the near-far interactor does not process this touch action. As a result, our finger does not apply a force to the cube, and the cubes in the scene are not pushed. The touch type input is bound to the XR poke interactor. However, a standalone XR poke interactor cannot push an object because the object is missing some related scripts that can interact with the poke interactor. Now we can first add the touch type of spatial input to the near-far interactor. This way, when we touch the cube with our hand, the near-far interactor can detect the touch type of spatial input and apply it to the XR grab interactable on the object. Thereby achieving the touch and push interaction effect. If you want to see the effect of the poke interactor, we can switch to another object. I'll use an object prepared by XRI called the push button. It already includes some scripts required for poke interaction. Here there is an XR simple interactable, which is of the interactable type, so it can be responded to by the poke interactor. The two scripts below are more important, as they are the ones that truly enable the functionality of the poke interactor. After adding these two scripts, the button in the scene can be pushed, and it is pushed from top to bottom. First, let's look at the XR poke filter script. It imposes some restrictions on the poke interaction. We can expand the poke configuration section. Here there is a poke direction parameter set to -y, which means the negative y-axis direction, or from top to bottom. This restricts the button to only be pushed from top to bottom. The poke angle threshold is a threshold value that limits the poke interaction to within a 45-degree angle. Next, the XR poke follow affordance script allows the button to be pushed a certain distance and limits how far it can be pushed. When the button is pushed to its limit, it cannot be pushed further. These two poke-related scripts extend the functionality of the interactable, allowing the interactable object to respond to poke interactions. To summarize, if we simply touch an object with our finger and push it to move, this is considered a near interaction. Near interactions are managed by the near-far interactor. Therefore, you need to add the touch type of spatial input to the pointer kind parameter in the spatial touch input reader, script associated with the near-far interactor. This allows the touch type of spatial input to take effect in the near-far interactor script. The near-far interactor can then influence the XR grab interactable on the cube objects to complete a near interaction. If we want to push a button, since pushing a button involves moving it in a specific direction, for example, from top to bottom, this pushing process is considered a poke interaction. In this case, we need to use the XR poke interactor from XRI, the spatial touch input reader. Associated with the XR poke interactor also detects touch input. When we touch the button, it activates the XR poke interactor. Which then acts on the interactable on the button object. In this case, the simple interactable. The simple interactable cannot handle grab type interactions. It can only respond to interaction actions initiated by the interactor. After the interaction is initiated, the XR poke filter and XR poke follow affordance scripts control the button's pushing effect, allowing it to be pushed from top to bottom until it reaches its limit and cannot be pushed further. Okay, now let's run the program to see the effect after these modifications. Okay, in the scene you can see that the button can now be pushed from top to bottom. This is the effect of the XR poke interactor. I can also use my finger to push the cube objects. This type of pushing is considered a near interaction and is controlled by the near-far interactor. This is the second method of handling spatial input. As you can see, its configuration process is slightly more complex than the first method. However, it allows us to use some of the more powerful interactors from XRI to achieve more complex interactions, such as pushing a button. If we were to use the first method of handling spatial input, it would be more difficult to implement this logic. Now, we can directly utilize the poke-related scripts from XRI to easily fulfill this requirement. What I demonstrated was object interaction in a shared space. If you want to perform interactions in a full space, you only need to change the volume camera configuration file to unbounded volume. The rest of the interaction process remains the same and is still applicable to object interactions in a full space. Additionally, if you choose the second method of handling spatial input, you actually don't need to add the Input Action Manager script. This is because the Spatial Touch Input Reader script will automatically call and activate the input action configurations from polyspatial at the underlying level. Therefore, the Input Action Manager is optional. Even if you delete it, the program will still run normally. Okay, that concludes the content of this tutorial. Stay tuned for the next episode.